Hello everybody and welcome. Thank you so much for joining me here today. In today's video, we are going to be talking about how to find the total interior angle measurements of polygons. We're also going to be talking about how to find the total exterior measurement. But let's talk about interior first. Here we have some polygon. It looks to be a hexagon. And how can we figure out what is the total interior measurement for this hexagon? Now remember, so what exactly am I looking for? Well, I want to know what all 6 of these angles added together will equal. That's what I'm talking about when I'm asking for the total interior angle measurement. So how can we figure this out? Well, let's go back to what we know. And something we know is that for a triangle, we know that the sum of its interior angle measures is 180 degrees. So my game plan for figuring out the total angle measurement, interior angle measurement for this hexagon is to split it into triangles and then sum those triangles. So let's do that. So what I'm doing here is I just picked any vertex on this hexagon and I am creating a line going from that vertex to any other vertex in that hexagon that is not directly next to it. Because if I drew a line connecting a vertex to another vertex directly next to it, it wouldn't form a triangle. It would just be part of the already polygon. So we're not doing that. That's why we're just drawing our lines to vertexes that are not next to the vertex we are drawing from. Okay, so with that, what do we have? Well, we have 1, 2, 3, 4 triangles. And notice that if we sum up all the angles of these 4 triangles, we will have the total interior measure of this hexagon. So if we take 180 and multiply it by 4, what are we going to get? We're going to get 720 degrees. Therefore, 720 degrees is the total interior measurement of this hexagon. Excellent. Let's try another example. So let's just draw another kind of random shape. Okay. Here we have a shape. This is a polygon, and it is a 7-sided polygon. So this is a heptagon or a septagon, depending on how you like to call your 7-sided polygon. Now again, let's just draw lines from one vertex to each of the other vertexes that are not directly adjacent to the one in which we are drawing lines from. Okay. Now that we have done that, let's count up how many triangles we have. We have 1, 2, 3, 4, and 5. Therefore, if I want to know the total sum of the interior measures of my heptagon, all I have to do is take 180 and multiply it by 5. 5 times 0 is 0. 5 times 8 is 40. 5 times 1 plus 4 is 9. So a septagon has 900, the total interior measurement for a heptagon is 900 degrees. Excellent, excellent. So is there a generic formula to find this, or are we going to have to draw triangles all the time? Well, there actually is a generic formula to find the total interior angle measurement of your polygon, and that's taking the number of sides. That's taking the number of sides. Here, let me write it down here. That's taking the number of sides, subtracting 2, and then multiplying by 180 degrees. This is your formula. Notice that we had a 7-sided shape here. 7 minus 2 is 5. And what did we do to solve for this shape? We took 5 and multiplied it by 180 degrees. In our last problem, we had a 6-sided shape, and we did 4 times 180. 6 minus 2 is, of course, 4. And then we multiplied it by 180 to get 720 for our total interior angle measurement of our hexagon. Excellent, excellent. So let's go down a little bit and let's talk about what's going to be the total interior angle measurement for each of these types of polygons. Okay, so remember that our generic formula is going to be n minus 2 times 180 degrees. So for a triangle, we of course know it to be 180 degrees. That one's really simple. For a quadrilateral, a 4-sided figure, we're going to have 4 minus 2 is 2. 2 times 180 is 360. For a pentagon, we're going to have 5 minus 2, and that's 3. And so we have 180 times 3. You can multiply this across and get 540 degrees. We already solved for a hexagon and found it to be 720. We solved for a heptagon and found it to be 900. What would an octagon be? An octagon would be, well, the number of sides is, of course, 8 in an octagon. 8 minus 2 is 6. So 180 times 6 is what? 6 times 0 is 0. 6 times 8 is 48. 6 times 1 is 6 plus 4 is 1080. So this would be 1080. Then for our nonagon, we, of course, are going to do the same thing. 9 minus 2 is 7. So 180 degrees times 7 is going to be 1260. And then for our 10-sided shape, we can multiply it out. 10 minus 2 is 8. And then 180 times 8 is going to be 1440. So our 10-sided figure will have a total interior angle measure of 1,440 degrees. Okay. Excellent, excellent, excellent. So next, here I already have some shapes drawn. I did my best to make them regular polygons. Again, regular polygons is where all the sides are the same length and all the angle measures on the inside are equal. Okay? So I know they're not perfect. I'm not the perfect drawer, but take these all to be regular polygons. Now, my question for you all is, what is the angle measurement of just one of the interior angles? Okay, here on this top shape, what is it? It's 1, 2, 3, 4, 5, 6, 7. This is a heptagon. We already found that the total interior angle measurement of a heptagon is 900 degrees. If you forgot, you can again use the formula, number of sides minus 2 times 180 degrees to get you the 900, the total interior angle measurement. But the question at hand is, what is the angle measurement of just one of the angles? Well, because these are regular polygons, all of the interior angle measurements are going to be equal. So if we want to find the measure of just one of the angles, we're going to take the total, which in this case is 900, and divide by however many sides there are. So this will be 900 divided by 7. Here, let's just round to the nearest tenth. So 900 divided by 7. 7 goes into 9 one time. We have 2 left over. Bring down your 0. 7 goes into 20 twice. When you subtract, we have 6 left over. Bring down your 0. 7 goes into 60 8 times. And then we have a remainder of 4. So let's just have a remainder. So our answer is 128 and 4/7 whenever it comes to what is the angle measurement of just one of the angles for our heptagon. Here, let's clean this up a little bit. Erase this work here. What about this shape here? What would be the angle measurement of just one of the interior angles? Well, this shape is 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. If we want to find the total, again, we're going to do 8 minus 2 to get 6. And we'll do 180 times 6 to get the total interior angle measurement. This is 1080. Now we're going to take 1080 and divide it by 8. So to find the measurement of just one of the angles. So 1080 divided by 8. And here I'm going to do this more quickly. I'm going to do short division here. And we get an answer of 135. So each of these interior angles are 135 degrees. Okay. Lastly, I want to talk about exterior angles. What is the exterior measurement for one of these polygons? Well, let's go over to this hexagon. Again, we know the hexagon to have a total interior measurement of 720 degrees. We saw for that in the very beginning. If we wanted to know the length of just one of these angles, we could divide it by 6. And whenever we divided it by 6, we would find it to be 120 degrees. Okay, so each of our interior angles for a hexagon are 120 degrees. Now, what if I ask you for what is the exterior angle's measurement? And what even is the exterior angle? Well, pretend like you just continue out the side length of your hexagon or of your polygon in question. This angle here that forms a linear pair with your interior angle is your exterior angle. Therefore, because your exterior angle forms a linear pair with your interior angle, that means the two are supplementary. Okay? So what is supplementary to 120 degrees? Well, 60 degrees is supplementary. Therefore, 60 degrees is your exterior angle measurement. Is there a quick way to find your exterior angle measurement without finding your interior angle measurement first? Well, actually, there is. Well, at least if you're dealing with regular polygons, shapes that all have the same side and interior angle measurements. And the shorthand is to just take 360 degrees and divide by your number of sides. If we did that here, 360 divided by 6 is what? Well, it is 60 degrees. And so you can see that this formula works. All right, there's a little mini lesson on interior and exterior angles of polygons. If you found this video helpful, let me know down in the comments below. Hit that subscribe button, and I'll see you in the next video.